All right, the last set of reflexes for this week are the withdrawal and the cross-extensor reflexes. And these are both going to be polysynaptic, similar to that last example of the knee-jerk reflex. And that inhibitory interneuron is going to be really important because we're going to have one muscle contract while the other muscle relaxes, just like we saw with that more complex knee-jerk reflex example. So let's look at these two examples. First of all, withdrawal. What is that? What is that doing? What's the purpose of this reflex? When you touch something hot or sharp, something that potentially is dangerous to your tissues, like would burn them, for example, you have an instinct to withdraw. This is the withdrawal reflex. To preserve tissues, to prevent damage, it happens automatically without you having to think about it. Will happen. And this is an innate reflex that even like babies will have. So let's look at how this works. First of all, you've got this hand that's touching a hot pan. And so this right here, this red, what do you think this is going to be? It's going to be a sensory neuron, right? It's going to be a unipolar neuron that carries pain and heat information to the spinal cord. So here's what that looks like. We've got this unipolar sensory neuron that synapses in the dorsal horn of the spinal cord. And it's going to synapse with another neuron. So before I draw the interneuron in there, I want to actually jump to what is going to happen in this direction. So what do we need the arm to do if we've touched a hot pan? We need that biceps brachii to contract. So we are going to have a motor neuron here that's going to connect to that bicep brachii. That's there. We're just going to draw the neuron there. This is the neuron that connects to the triceps brachii. Let's add that in as well. Now we need to connect these with how we want these two neurons to act, respond to this painful stimulus. You should already be able to think that we want this black neuron to be activated and the blue neuron to be inhibited. That's going to allow our hand to do this, to flex. We want our arm to flex in this case. So in order to do this, we're going to draw an interneuron that I'm going to draw kind of this greenish color here. And so this sensory neuron is going to synapse onto a single neuron that is excitatory, and it's going to excite that blue guy there. I'm sorry, that's the wrong way. It's going to excite the black neuron. We've also got the same neuron is going to synapse onto another interneuron. I'm going to draw this very small here. I'm going to draw this in yellow, just have a different color. Here is that second neuron like this. That yellow, I don't know why I'm writing yellow. I could just write this, right? This is what I drew. This is an inhibitory neuron, the only inhibitory neuron shown here. Sensory information is stimulatory. It's a positive. So glutamate might be released from this neuron right here. This green neuron, it's an excitatory neuron. It releases glutamate. Just that's what it releases. It can't release more than one thing. Got a positive there and a positive right there. However, this neuron, the one you can't see very well, this is an inhibitory interneuron. It's releasing GABA to inhibit the blue neuron. Thereby, we've got the same original stimulus, which was touching the hot pan, is going to cause an excitatory effect on one motor neuron and an inhibitory effect on another motor neuron. That's how we have the biceps brachii contract and the triceps brachii not contract. Remember, you can't actively cause a muscle to relax, but you can inhibit its contraction to allow for maximum flexion. Here is that same thing with a diagram, not drawn by me. So you could walk through this as well. Same thing, just these neurons are a little bit better drawn than mine, but drawing it is what helps you learn. So I want to model that for you. Here's our excitatory sensory neuron. And let's go ahead and add in the fact that this white interneuron is also excitatory, but the blue neuron, this is our inhibitory interneuron that tells the blue neuron not to fire. So this is our inhibitory interneuron that only connects to one of our motor neurons, not the other. Notice also there is information that's traveling to the brain to allow, as well as other spinal segments, that's could be important for the rest of your body to respond, as well as letting your brain know that this happened. So again, as the biceps brachii contracts, the antagonistic tricep brachii need to relax. And this should be clear that because the neuromuscular junction is only excitatory, we can only inhibit firing. That's why this interneuron is so important here. This is called reciprocal inhibition. The inhibition at the same time as that excitation is occurring somewhere else. Okay, I actually want to pause here. I'm going to do cross extensor in a separate video just to shorten things up a bit. It's a very similar idea, but a little more complex.